All right, imagine looking at your very first job offer right out of college and seeing a figure like 2.8 million rupees. That's 28 lakhs per annum. Sounds a bit like an outlier, doesn't it? Something reserved for elite PhD researchers? Well, actually, what if I told you that in today's hardware-first world, this is literally the gold standard waiting for a fresh graduate who really knows their way around a Verilog test bench? Welcome to the high-stakes, incredibly high-reward world of semiconductor engineering.
Hey everyone, and welcome to this Masterclass Explainer. I am absolutely thrilled you're here. Today, we're putting on our industry veteran mentor hats to take a deep dive into the Bachelor of Engineering in VLSI Design and Technology. We're going to break down exactly how you can turn this specific university degree into a highly lucrative, entirely future-proof career. We'll be unpacking the curriculum, scanning the hiring landscape, and mapping out the exact strategic moves you need to make to land those top-tier jobs right out of the gate.
Okay, let's dive into this. Here's our roadmap for today. First, we'll hit the silicon gold rush, then explore those high-paying roles. After that, we'll map out your curriculum roadmap, make a few strategic comparisons, and wrap the whole thing up with some actionable mentorship advice.
All right, kicking things off with Section 1, the Silicon Gold Rush.
To really understand why salaries are surging like crazy right now, we first need to grasp the massive shift happening globally and especially domestically in India. The industry here has completely transitioned from being just a back-office support hub to a frontline design powerhouse. And to put that into perspective, by 2030, the global semiconductor market is expected to rocket past $1 trillion. This explosive growth, it's being driven by absolutely undeniable megatrends: the massive push for AI-native silicon, the rapid adoption of EVs, and the global rollout of 5G and 6G. And guess what? All of this relies entirely on physical manufactured chips. Because of this massive global demand, we're seeing an unprecedented talent shortage. There are literally only about 125,000 VLSI engineers globally right now. That makes this an incredibly rare and very, very valuable skill set.
And this brilliantly illustrates why a specialized degree is practically your golden ticket. Look, a BE in VLSI Design and Technology isn't just another generic engineering program. It is the ultimate, future-proof launchpad for this booming hardware-first world. You aren't just learning basic electronics here. You're specializing in chip architecture, semiconductor devices, and integrated circuit design, which, by the way, is the exact foundation that this trillion-dollar market is so desperately looking for.
Moving right along to Section 2, high-paying roles and salaries. Let's talk money.
Because this skill set is so rare, and because the cost of making a design error is just so incredibly high, companies are more than willing to pay a massive premium for the right talent, even straight out of college. We're talking the heavyweights here. A fresher joining NVIDIA as a hardware engineer, they can expect between 22 to 28 lakhs per annum. But you know what turns NVIDIA's package from just great to literally life-changing? The restricted stock units, or RSUs. That gives you actual ownership and massive wealth-building potential in a booming company. Then you've got Intel offering 18 to 24 lakhs, which is an incredible learning ground for SoC or system-on-chip design. Texas Instruments, who are legendary for grooming fresh grads in analog circuits, they're offering 19 to 25 lakhs. And Qualcomm, the absolute masters of connectivity, coming in at 17 to 23 lakhs. Guys, these are starting salaries that rival and very often beat elite software developer packages.
Now, what's really interesting about this is the exponential trajectory. Sure, if you don't land at a top product MNC right off the bat, you might start around 4.5 to 6 lakhs as a fresher. But just look at that growth. Within 3 to 5 years, mid-level engineers are typically hitting 15 to 25 lakhs. By year 7 and beyond, senior engineers are commanding 40 to 60 lakhs and topping out well over 80 lakhs in total compensation. That's what exponential long-term growth really looks like.
Which brings us to Section 3, the VLSI Curriculum Roadmap.
So the big question, how do you actually secure that money? Well, it all comes down to connecting those high salaries directly back to the specific skills you're going to pick up during your BE program. The curriculum is super structured. In your second year, you're building the foundation with digital logic and circuit theory. This is the absolute bedrock of everything you'll do. Then, by year 3, you're diving deep into CMOS, analog IC design, and RTL, register transfer level design using Verilog. This is where you learn to actually write the code for the chip's logic. And finally, in your 4th year, you tackle the advanced stuff, like system-on-chip design and VLSI testing. Every single one of these subjects maps directly to a specialized, high-paying job title in the industry.
And here is exactly how your academic syllabus translates into the professional workflow.
The real-world chip design process flows like this: design, then verification, optimization, physical layout, and finally manufacturing. Those courses you take, like RTL Design, verification methodologies, and physical design, they are literally the steps of this exact workflow. You're not just sitting there learning theory, you are simulating the precise daily process of a working engineer at Intel or AMD.
Now, within that workflow, different roles command different levels of demand. Notice how verification engineers are highly sought after? Why is that? Well, because you simply cannot fix a physical semiconductor bug with a quick software update over the air. No way. A mistake caught after fabrication costs millions of dollars. Because of that, engineers who use System Verilog and Universal Verification Methodologies, or UVM, to stress test these designs, they prevent those multi-million-dollar disasters. And that is exactly why they command top dollar in the market.
Moving into Section 4, Strategic Comparisons.
As an engineering student, you've got some big choices to make. So let me keep my industry mentor hat on and tackle the elephant in the room right now: software versus VLSI. Here's the hard truth. Software might pay really well on day one, and generally it has a lower barrier to entry. But software frameworks become obsolete pretty quickly. VLSI, on the other hand, definitely has a steeper learning curve. However, that steep curve is actually a blessing. It acts as a barrier to entry, keeping your competition way lower and protecting your long-term market value. Basically, software wins early, but VLSI wins the whole career. By year 5, VLSI engineers consistently out-earn their software peers.
You're also going to have to choose between company types. Product giants, think Intel, NVIDIA, Samsung, they control the entire stack from design right down to deep R&D. The salaries there are massive. Service firms like TCS or Infosys sit a bit lower on the pay scale, but listen carefully here. Service companies are fantastic launch pads. A really strategic move is often to start at a service company, build up some foundational experience for about 2 years, and then job hop straight into a product giant to completely reset your salary ceiling.
Finally, Section 5, Strategic Moves for Freshers. Let's talk execution. So, the crucial point is this. If you want to graduate in 2026 and immediately step into the upper brackets of this industry, location is absolutely crucial. You literally have to go where the fabs and design centers are. Bangalore is the undisputed top hub. It's got the highest concentration of VLSI companies, hands down. Hyderabad is a very close second and arguably offers the best value. The salaries are almost as high as Bangalore, but the cost of living is roughly 20% cheaper. Noida and Pune are also growing rapidly. But to truly maximize your earning potential, you need to be fully prepared to relocate to one of these major tech hubs.
I want you to remember this rule. In VLSI, skill is absolutely your currency. Having a base degree gets you into the room, but your specific knowledge of the tools, that's what gets you the actual offer. If you're a fresher who's proficient in System Verilog, who understands UVM, or knows the fine nuances of static timing analysis, ensuring signals arrive exactly when they need to on a microscopic 5-nanometer node, you will always sit in the upper tier of those salary brackets we talked about. You gotta master tools from Cadence and Synopsys.
I really want to reiterate this powerful takeaway because it's so important. It requires patience. You're going to have to study harder, run hundreds of simulations before finalizing a design, and you have to continuously upskill. But the stability and the financial reward you'll see by your 5th year, unmatched. You are building a rock-solid skill set that doesn't just go obsolete in 2 years like a JS framework.
Let's move to and see how this builds your long-term potential. Because once you have these fundamentals down, you can build your value even further by specializing. Right now, the absolute highest ROI skills are AI chip design and advanced 2-nanometer node architectures. Having internship or project experience in these futuristic areas, or even in EV power electronics, that can instantly add a 4 to 6 lakhs per annum premium right on top of your starting salary. Ultimately, you aren't just looking for a paycheck here. You're securing a front-row seat to the most exciting technological revolution of our time. The code you write and the layouts you design today are quite literally going to power the AI, the electric vehicles, and the communication networks of 2030. The industry is desperately looking for focused, hungry learners like you. So hit the books hard, master your tools, and get yourself ready to lead the Silicon Gold Rush. Thanks so much for joining me on this explainer, and I'll catch you on the next one.